Now we're going to talk about two ways to label a series, not whether it necessarily converges or diverges, but we're going to determine whether a series is going to be labeled absolutely convergent or conditionally convergent. And basically these are the definition. If you look at the absolute value of the series itself and the absolute value of the series converges, we can say actually that the series itself, we're going to call it absolutely convergent. If the absolute value of the series diverges, but then when you actually look at the series with the negative sign as well, converges, then we're going to call it conditionally convergent. Okay, so we're going to work through three examples, and what I always check first is check the absolute value piece first, because if this converges, you already have your conclusions it's absolutely convergent. If this diverges, then you're going to have to go ahead and check the series as well. If both pieces diverge, then you just say it's a divergent series. Okay, so let's look at the first example here. So first thing I'm going to do is I'm going to just take the absolute value of the series. So the absolute value piece would just be this, right? Just look at the series without the negative 1 in there, the negative 1 to the n. I can say right away that this is a p series that diverges. So because it diverges, this cannot be absolutely convergent. Okay, now if it diverges, you also have to figure out what happens to the entire series with that alternating sign. For this particular series, this is an alternating series, so I'm going to use the alternating series test. So is it true that the limit of the general term goes to 0? Yes, that is true. Is it true that the n plus first term is less than the nth term? Yes, this is true, so we would say this converges by AST. Or again, instead of writing the two conditions, if you can tell by looking at it that the numbers get smaller to 0, you can say absolute value of the terms gets smaller to 0 or decreased to 0. But because the absolute value of the series diverged, the series itself actually converged, we call this original series is called a conditionally convergent series. Okay, let's look at the next one. Again, I always start with the absolute value piece. So let's look at this. Okay, and you need to figure out what test we're going to use. I'm going to use the nth term test on this one because if I take the limit of this, the limit is 1, which is not 0, and the nth term test says if it's not 0, we know it diverges. Okay, and on the series with the alternating signs, this is an alternating series test. So I'm going to do the alternating series test, but the first condition is it true that the limit goes to 0? And we just figured out the limit here. This is not 0, so the series itself with the alternating sign also diverges. So if both pieces diverge, then we're going to label this as divergent. Okay, last one here. Again, I start with just the absolute value piece. I know that this is a geometric, because r is 1/3, I can say it converges. So if the absolute value of the series converges, it's called absolutely convergent. You are done.